Hey, how's it going everyone? Welcome to this video. In this video, we're going to have a look at example 15, where we've got the graph of sine x and the y equals 1 take 2x. And the first part of the question says to sketch both of the graphs on the same set of axes. So let's go ahead and do that. So we've got our set of axes, sine of x. It hasn't been translated or dilated, so we simply start at 0. We're going to have an amplitude of 1 to -1, and we're going to go over the interval, say pi on 2, pi to 3 pi on 2, and then to 2 pi. So between 0 and 2 pi, we're going to go up to 1, stop at pi, down to -1, and then 2 pi. So if we connect the dots, okay, it's going to look something like that. So that's the y equals sine of x, and the line 1 take 2x. Let's say x-intercept y equals 0, so x is going to be 1 over 2, and the y-intercept at x equals 0, we have 1. So it starts at 1, crosses at about 0.5. So if we connect the dots there, alright, looks roughly something like that. So as we can see, the line sine x and 1 take 2x only has one intercept, which is a graphical explanation as to why they only have, so y sine of x equals 1 take 2x has one root. The second part of the question says to use the graph to give an interval in which the root of the equation lies. So as we can see from the graph, it can be seen that the root lies between the origin, which is at 0, and the x-intercept of the line, which is about 0.5. So we can say the interval in which the intercept, or the root, so it lies between 0 and 0.5. And third part of the question, use the bisection method to create two narrower intervals for the root and hence give an estimate for this value. So starting off, we've got sine of x equals 1 take 2x. If I rearrange this equation, so I have sine of x take 1 plus 2x equals 0, and we can find that x equals 0. The sine graph lies below the line. So at x equals 0, the sine graph lies below the line, so f of 0 is therefore less than 0, and we can check that by putting 0 into the equation, and if we do that, we get roughly -1, which is obviously less than 0. And we also need to check at x equals 0.5. So sine of 0.5, take 1 plus 2 times 0.5. We get an estimate of out 0.48, which is obviously greater than 0. So the midpoint between 0 and 0.5 is 0.25. So f of 0.25, sine of 0.25, take 1 plus 2 times 0.25, which is minus 0.25, obviously less than 0. So the root lies in the interval between 0.25 and 0.5. The midpoint of those two is going to be 0.375, and then finding f of 0.375 gives us 0.116, which is greater than 0. So we're getting a closer estimate of 0.25 and 0.375, and we're going to stop it there. So the midpoint is an estimate of the root, so it's going to be about midway between those, which we'll find as x equals 0.3125. So that's using the bisection method to find an approximation for that value there, where they intersect. So that's example 15. In the next video, we'll have a look at example 16. Thanks.